Okay, here is warm up 9.4. So I've got this diagram. I've got a big right triangle that is cut up into two smaller right triangles. Since this is a right angle here, this would be a right angle as well, right? Okay, because that line's perpendicular to this. Okay, so first it says sketch the medium and small triangle. So the large triangle, I mean, that's the big one here. I've already got that sketched. I'm going to sketch the medium one first, so the medium-sized one, and I'll just color code this a little bit. I'm talking about this one here. Okay, so I'm going to draw it down here, but I'm also going to flip it around so that it's it's turned around the same direction as the large triangle. So that in the large triangle, I got the right angle at the bottom left corner. So I'm going to do that here. Okay, and I'm not measuring anything out, just a little sketch, okay? And then in this small triangle, I'm going to put the pieces on. So X would be the shorter leg. Okay, I don't know the length of the longer leg. It's part of 26, but 26 is that whole thing. But then 24 is the hypotenuse of this pink triangle, right? So let's put those pieces in place, okay? Then my small triangle, I'll color code this green. And again, I'm going to flip this around so that I've got the right angle in the bottom left corner, okay? So let's see, X would be the longer leg on this triangle, so that would go down here, and then the hypotenuse of that triangle is 10, okay? Let's also label the vertices. So on my pink triangle, let's see, the right angle is at D, and then if I go to the up X, I'm going to get to the B, and C's at that corner, okay? The right angle and the green triangle is also D, and the short leg would bring me to A. If I go from D to down to the long leg, that brings me to B. Okay, so I successfully sketched those triangles, okay? And now that I've got them all facing the same direction, it's a little bit easier for me to write this similarity statement in the next problem. So there's going to be shared angles here, which means, and some shared sides, which would give me similar triangles. So I'm not going to go through explaining that. But when you have a large right triangle cut into two smaller ones, all three right triangles are going to be similar. Okay. So triangle ABC, that's the large one. Okay. And then my medium, I just want to go in the same order. I went A, B, C, so I want to go B, D, C, so that I get, A would match up with B, B would match up with D, and so forth, right? So I want to go in the same order. So this would be BDC for my medium. And again, I went like that, right? Going to do the same thing with the small one, ADB. Okay, and now, I've got the corresponding corners in the same positions for all three triangles, okay? So now let's solve for X using a proportion. So, excuse the bell, sorry. Okay, so I've got some different options because I have X in both these triangles. I actually don't need both of these triangles. You can use either one. So let's just throw away the green triangle for now. I could do this with just these two triangles. So the X would match up with the 10, right? These would be corresponding pieces. I can see that because they're in the same positions. All right. And then I've got matching pieces with the 24. I need to match the 24 up with something that's going to match with the 26. So now I can say X is to 10 as 24 is to 26. Or you could have this whole thing flipped upside down. I could have went that way, but I went up. I went X to 10, 24 to 26. Okay, you just need to be consistent. All right, and then I can cross multiply from there. You could also reduce this fraction if you want, or you can just go straight to cross multiplying. It doesn't really matter. So 26x, then 24 times 10 is 240. Okay, and I'll divide by 26. Okay, so then I can leave, my answer is going to be 240 over 26, but I'd want to reduce that. So those are both even numbers. I could divide them by 2, and then I've got 120 over 13. 13 is a prime number, and it doesn't go into 120. So this is reduced. You could leave it like that, or you could do a decimal approximation. You could, put that into your calculator as 120 divided by 13. That would bring you about 9.2. And there we go. Okay. So to solve for x in a problem like this, you could go through all these steps, rewriting the problem. Well, you don't have to rewrite the triangles, but it makes it a lot easier to set up your proportions correctly if you do draw the smaller triangles separately and get them all facing the same direction. But there are also some shortcuts you can use with geometric mean. Okay, so if you want the geometric mean between two segments, there's a little formula. And when we've got this segment inside a triangle, like this is the same situation. This would be this piece, right? So this is going to be the geometric mean between 36 and 64. Okay? It's going to be when you have a segment inside a triangle like that that divides the hypotenuse into two segments. That this altitude here is going to be geometric mean between those two. Okay. So, little formula for geometric mean. The geometric mean between two numbers is going to be equal to the square root of those two numbers multiplied together. So let's say I wanted the geometric mean of a and b. I take the square root of a times b. So here, since x is the geometric mean between 36 and 64, then it's going to be the square root of 36 times 64. Okay? And then I want to put this in simple radical form. You could just multiply it together, and actually will come out to it, it'll be a perfect square. You might notice these are both perfect squares. But I'm going to break this apart looking for twins. So 36 is 6 times 6, and 64 is 8 times 8. And once I find a twin, they can make a break out of jail. So one of them distracts the guards and gets sent to solitary confinement, goes away. But the other one gets out. So a 6 is going to get out, and then an 8 will get out from this group, and then there's no one left in the jail, so we don't need the radical anymore. And then I do the multiplication, and that's going to come out to 48. Okay. All right. So we can also use geometric mean when we're dealing with my 6 here is on the outside of the triangle. It's one of the legs of the triangle. Okay. So here's the trick with this one. 6 is not the geometric mean between this piece and this piece. 6 is going to be the geometric mean between the close piece of the hypotenuse, and by I mean, so I've got these two parts of the hypotenuse, but the x is closer to the 6 than this other piece is, okay, and the whole hypotenuse. All right? So 6 is going to be the geometric mean between x and 12 then, okay? 6 is the geometric mean, so that would go in this position, right? And then it's the geometric mean between 12 and x, so I'm going to take the square root of 12 times x. Okay. All right. So I want to solve this for x. Just to clean this up, I can just write this like so, right? So I want to solve for x. I want to get x out of this square root symbol. It doesn't have a twin, so I can't get it out that way. But what I can do is square the whole equation. So 6 squared is 36, and then the square and the square root undo each other over there. And now I can solve this equation by dividing by 12. Okay, and 36 divided by 12 is going to be 3. So x equals 3, and there is my solution, right? And you could also set up similar triangles. That's another way to do it, but it's kind of a shortcut using geometric mean. Okay, that's the end of the warm-up, and I'll see you next time.